So, hi everybody to another episode of Data Analytics with datadice. Today it's only Alex and me, Thomas. Ricardo is not around today as we are talking about cloud solutions. So different like cloud providers for doing BI and doing data analytics. And for that we we would like to compare the four biggest ones at the moment on the market. At least it's our feeling that those four are the biggest ones. So Alex, tell us the names.
Yeah. So it's Snowflake from Snowflake. Then we have RedShift from Amazon. We have BigQuery from Google, and we have Azure Synapse from Microsoft. So we have three big IT companies, three big IT providers.
Solutions, so to say. Yeah.
And we have Snowflake, which is also now a big company. But yeah, in terms of where you can find them and so on, it's a little bit different than the other third, I would say. We also will mention some aspects here. But that's quite interesting.
Yeah, we have to say we are a little bit biased to say that at the beginning. We are using BigQuery since multiple years. We are using Snowflake with clients, but also for projects from us. We're not using Azure. We are not using RedShift for us for different reasons. But it's not about us today. It's more about what are the differences in those cloud solutions. And I think that's a very important point at the beginning. If you think that some like informations are not correct, of course we research them. Of course we try to give them exact as possible. But if you are like a user of Azure or RedShift or also the other two, and you think you have to like correct something, please do that in the comments. Please don't hesitate to do so, as we can also learn from that. And it's also important like for the community who watches that video. I think there are four main things we need to compare. That's first of all, we start with administration and management. So how much do we need to do to set up the project, keep the infrastructure running, and things like that. Second of all, we will talk about scalability. That's important for also like how are you developing as a company, as a private person with your project inside the next couple of months, years, and what does it mean with a cloud solution like that? Third main point is the ecosystem. So what's ecosystem, Alex?
Yeah, so all the other parts of the BI solution you should choose or you have to choose. So not just the data warehouse. It's important for a data warehouse that it connect to other tools to get the data and so on, to transform it and also to show it. So these are important aspects, and we want to take a closer look on all of the ecosystem there out.
Yeah,
and the fourth one is also a big aspect, an important aspect for sure, the pricing.
For a lot of you, I guess.
Yeah,
pricing.
Exactly. So these we will also separate and take a look into each. Yeah, exactly.
Then I would say let's start with administration and management.
So administration management, we mean exactly in terms of how can you start with that tool in terms of really collecting data and transforming it and so on. So which steps you have to do. And in terms of is it serverless or do you have to add nodes and so on for computing and storage. So these are things which are important for data warehouse, and you have in terms when you're planning a project with which tool you are going.
Yeah, I think first of all we have to say that when we talk about those four solutions, where do they differ, right? And where like are they positioning themselves? A lot of questions going around in this BI area is like which cloud solution should I use? And first of all, we have to say that this answer is not like, that's not an easy answer to give. And it's also not this one answer to give to everyone. First of all, it really depends on the use case your BI solution is basically built on, or what you want to like achieve with that, what you want to analyze, and how basically everything around that solution looks like. So if we talk about administration and management, maybe you, Alex, can again start talking about BigQuery, because we as an agency are using BigQuery quite a lot. So we are quite, so we know BigQuery quite well, while maybe have not every detailed information about the others. But we will try to talk about that as fair as possible, that it's not going only into one direction.
But yeah, as you said, so administration management. So again, it is completely serverless. So that means you don't have to add some nodes or cluster to it, or you have to be aware of computing resources and so on. Everything is provisioning from Google automatically, and that's really easy. So if you have 90 days, the first 90 days of the project, just really easy queries, not much data inside, you can already query it. But if you have then on day X a lot of not new data and a more complex query, you can just put it in and query it and execute it. And BigQuery say, okay, now he needs more, and you do it automatically.
So to say, it's super easy to start with a project, and you don't need to invest a lot of time, and you don't need a lot of experience at the beginning to start a data warehouse project.
So it's really easy to start with a project, right? So you just need a Google account, and you just need to create a project, and then you can already start. You don't have to put in your credit card numbers or your credit card. You can, but you have a free amount of costs or spend you can do. So $300 for every project. Yeah,
no,
for every organization.
For every organization. At the end, yeah. So whenever you create a new organization where you also have a new billing account added to it, you will get those $300 at the end again. That helps massively at the beginning, because you don't need to take care so much about cost, and you can start right away with whatever you are trying to design. Plus, you also have those free tiers, free limits you can use for every tool inside the GCP, let's say, ecosystem. And they are not that small, to be honest. So when we come to that a little bit more in the pricing part, because then we can explain it a little bit more in detail.
Yeah. I can quickly mention our Udemy course, because there, for example, right at the beginning, I think in 10 minutes, maybe 15, not sure. We had nothing in the beginning, and then we created a Google account, a project, and so on. We put in some data from the BigQuery public data sets, created a Data Studio report, and in 15 minutes you have your first Data Studio report where you are analyzing your data in BigQuery. So that's really cool.
So next one, RedShift. Let's compare RedShift to BigQuery a bit. RedShift is the other extreme, I would say. So you need some experience already before you start with that. Of course, I think you can also quickly set up a node and maybe some storage option. But for increasing the performance, for making it more based on your needs, you probably need to test a little bit around, and you maybe also need to know a little bit more about what kind of nodes you need. And this will always be the manual part of the database itself. So it will never run fully automatically. That can be good. That can also be, so it can be advantage, it can be a disadvantage. For your time and the stuff you would really like to do in terms of data warehousing, it's probably a disadvantage, because you need to invest more time. For the flexibility and for the reason of tweaking the database, it could be an advantage, because you can really say how many nodes your database is running with, and
it's also easier for the pricing, right? So you know which nodes you are activated, which clusters, and you can estimate a little bit better how much your costs are.
This we can discuss a little bit deeper in the pricing part.
So then we have Azure Synapse, for example. So this is in the middle, I would say, because it offers two types. So it offers a serverless option, which can you compare maybe with BigQuery, and there's a dedicated option. So you can say, okay, I want this server And later we also coming to that you can also put in there some new capacity of storage and of computing and so on.
That's first of all quite cool that you have the option to use both, serverless or dedicated. The last one is Snowflake. Snowflake is a little bit, it's an interesting option. I mean, Snowflake was pushing more and more into the market the last years. Super big solution right now already, used by a lot of companies. And it's a little bit different to Amazon RedShift, Google's BigQuery, and Microsoft Azure, as Snowflake is basically running on their infrastructure. So you can select which kind of vendor ecosystem you would like to use with Snowflake, and Snowflake gives you basically the Snowflake ecosystem around that, including the database, with a lot of special functionalities, options. So not so much maybe different to the other vendors, but they solved some problems at the beginning where others maybe had those issues back in the days. Talking about scalability, I think first of all it's quite similar to administration management. It's
also in terms of the ranking of the different tools and so on, it's nearly the same. So BigQuery is again easy, right? So storage and compute independently. And it's also automatically handled by BigQuery. So it's really easy. As I already can take the same examples I did for administration management. It's the same for scalability. Azure Synapse, here we also have to differentiate between the serverless option. So that is also nearly handled or similar handled as BigQuery. But as I said already, in the dedicated option, you have to say, okay, I want more storage or I want more computing, and that you have to add manually.
Yeah, for Snowflake and RedShift, storage and computation part is handled separately.
Yeah, so maybe for RedShift, a quick addition. So RedShift offers some nodes, as we already said. And there are different kinds of nodes, right? So you have SSD nodes and HDD nodes. So for example, if you are estimated you need more computing power, for example, but not so much storage, maybe it would make sense to put more SSDs inside. And if you have more storage, but maybe not so complex queries, then it makes more sense to put HDD inside. Mm-hmm. So these are little things you can then adjust, and you also need then experience with that tools to really get the most efficient one. Yeah, so ecosystem. Maybe so at first you have to say, maybe we can put out Snowflake at the first a little bit, because it's, as you already said, you can select the cloud provider. But for the other three tools, if you have your whole ecosystem inside AWS or Microsoft or Google, it makes sense to also put your data warehouse inside. But just to mention, if you have the whole Google, or if you use the whole Google or the whole Microsoft ecosystem, you can also use BigQuery as the data warehouse if it fits your needs. As
maybe to give some example here. So with ecosystem can mean two things. So first of all, let's say your whole company, like the compute parts of your operational databases and so on, of your IT system is running on AWS. We don't need to say we have to run our analytical infrastructure also in AWS, because AWS is quite well connected to BigQuery, to GCP, for example. Like you can exchange super quickly data between the storage tools, and that works really, really good in 2.21 now. While
it's also easier for security, right? So if you have
that's definitely true. Yeah.
So if you have the whole identity and access management inside Google, for example, and then your whole GCP project, it's already good project. Then it's really easy. But if you then need also Microsoft, and then you need Google also ID and so on. So that's also
I think more important what you mentioned is the ID, right? Yeah. If your company is running on Microsoft ID, like using Teams and 365, then It's not that easy to then go to the Google Cloud environment because it's easy. You just have to create a separate ID for every of the employees. But in bigger organization, that requires a lot of additional administrational stuff and so on. So in that case, it maybe makes more sense to go with an alternative where you can use Azure or with Snowflake and Azure. AWS probably have the same issues as with GCP because you need to create some users. Talking about the users, I think they are in all of those cases free. You can book some additional tools to that. In GCP, that would mean that you need a Google ID, like Google Workspace ID. It's called Google Cloud Identity, or Google Identity, not Google Cloud Identity. You can go for premium options. Then you have better SLAs inside and so on. And then you pay, I don't know, $5, $8, something like that per month and per user. But you don't need to do that. Yeah, you can go for the free option. Those are basically the things about ecosystem when it comes to user management, as well as important as that is what kind of tools you're using to handle your business day in, day out. Thinking about, again, the cloud solution you're using for user management, like for your emails, for your spreadsheets or Excel sheets, there it's also important. If you have all the Excel sheets in Microsoft Excel, or you have them in Google Spreadsheets, that helps you a lot with bringing the data or enriching data in your analytical solution. So if you have everything in Excel and you use Google BigQuery without any third-party tool, it's not that easy to bring the data in real time into your database. While if you're using Google Workspace and you use Google Spreadsheet, you can easily connect your analytical database with your Google Spreadsheets. And every time you type something in your spreadsheet, it will be updated in real time in your database. And this is quite a cool feature, which really helps, for example, inserting marketing data, which cannot be transformed via an API or inserted via an API. There it really helps for working together inside the company and also using that data and not only have it in a spreadsheet lying somewhere.
Yeah, we have, for most of the customers, we have an input sheet, we mostly call it, right? Mm-hmm. So where you can say, okay, here we have, for example, if you have new marketing channels or whatever, or some new names, namings, conditions, and so on. So this you can all define in the Google Spreadsheet, for example, or in Excel. I think it's also possible for Microsoft. And if the customer changes something and they don't have to write you and say, okay, you have to change something in the data warehouse, you just put it in the spreadsheet and it's then updating in the data warehouse and then also maybe in the analytics tools. So that's really easy.
So it's part of your automation, but there will be manual input from any employee, for example, or any stakeholder. And this is quite cool thing to use. What else? One big part for us is always marketing tools. That's Google Analytics, GA4 at the moment. So the most, at least, important one, and Google Ads. So both are integrated directly into Google BigQuery, and that's why we favored years ago the Google basically ecosystem over maybe Azure and AWS. I think that was one of the most important reasons, as we didn't need to take care of a lot of hassle importing that data and trying to transform that. Plus, of course, the nice scalability that we don't need to take care of, setting up nodes.
Yeah, so maybe to wrap up quickly this ecosystem. So every of all of the four tools are having a lot of possibilities to put in the raw data, have their own APIs to do that, and they also have a lot of possibilities to visualize the data, so that is possible. But yeah, for example, we have also the case, we know people who are using Microsoft, but then have a Snowflake data warehouse. So that's also possible.
Which works
but as we said, because Snowflake you have to pull out a little bit because it's it's relied, or it takes, or you can use Snowflake with all of the cloud solutions. So that's really easy. So
then we have 3 points which are like completely the same for every cloud solution. That's data backend and recovery. So you never need to take care of like data backup yourself. That will be done from the analytics solutions right away.
So that, for example, was a little bit of a disadvantage of BigQuery some weeks or months ago.
Some month ago.
I already checked it before we recorded it. So you have now these table snapshots, they call it. So you can put, or you can say from the last 7 days, or last 7 days ago, you can say, okay, I want this data from this table from 5 days ago. You can define it at the timestamp.
And then you have exactly that snapshot. So you can really travel back in time. I'm not quite sure how that was with Azure and RedShift. You can help us in the comments if you know if that was possible and how that was possible. But I know that in Snowflake it was already possible a while ago. But now also BigQuery did some improvements here.
Also, if you already deleted the table, it's also possible to go back 7 days. And you can clone that data then, and then you have a new existing table with the snapshot of the data.
It really gives you an additional layer of security at the end while working with important data that you don't delete it by accident.
So then we have the Columnar architecture. So every data warehouse saved in a columnar way. So that is important, especially for analytical databases.
So normally what's happening is in operational databases, you store row-based. And whenever you would like to delete a row, you simply do that, right? For columnar architecture, it's the other way around. So if you say, if you have 100 columns and you would like delete one row, you have to say, okay, I need to delete one single cell out of every column at a certain index. So that's, as you can imagine, way harder for the database than just to delete one row. But on the other side, makes analyzing data way quicker. Let's just imagine you would like to sum revenue. For row architecture, that would mean we have then to do the same operation as deleting a row. We have then to like summing a column, and then we have to search for every row exactly the value inside that row, right? And this is way more like, this takes way more time than to just say, okay, we have that column and we just sum it up.
So grouping and aggregation is faster in analytical databases as in
and
operational.
They all have them because in those big ecosystems, Synapse, BigQuery, RedShift, but also Snowflake, they are designed for analyzing big data. That's why it's basically all the same. So the last but not least, I would say, is obviously pricing. Pricing is always a very important topic for everyone. First of all, we need to say that for most of the solutions, that's a flat rate pricing. So what you can do is like you pay a certain amount per month, which is normally nearly around 10,000 euro, I guess, per month. And then for BigQuery, for Snowflake, for all the others, you have basically unlimited resources for a certain configuration, I would say. But this is not the main focus we would like to set today. We would more talk about the on-demand pricing.
Because we have the experience that most of the customers and people are using on-demand pricing.
Exactly. So if you think about using a flat rate pricing, you are probably working for a very big company, and then some other aspects and research need to be done anyway before I choose like this flat rate pricing. On-demand pricing is normally, again, splitted or separated into computation part and storage part. We could start with the storage part as it's easier to explain that. It's always calculated per terabyte. So per terabyte you store, you pay a certain amount of price. For 3 of those solutions, it's roughly 20 to 25 euros. For example, for BigQuery, you pay $20 per terabyte for active storage. Maybe one quick X-course here. What does active storage mean? When you frequently use that data, it's active storage. If you didn't use that data for more than
90 days?
90 days, thanks
We
for
checked
90
it
days,
quickly.
you checked it before, then it's going automatically to long-term data, so you don't need to set up anything. It's automatically for every table where there's data inside. This will switch to long-term data, which is then half the price, so $10 per terabyte. The moment you again use it, from that particular moment on, you will pay again the active storage for that particular table. The other two, Snowflake and RedShift, are at $23 per terabyte and $24 per terabyte. So there's not really a big difference. Also, compared to BigQuery, it's like we're talking about $3 here.
Storage is also not the bigger part here in terms of cost, right? So then we are coming to computing.
But we forgot one solution. That's Azure. And Azure comes with a price of $123 per terabyte. And I checked it 2 times because at the beginning I could not understand why it is that much higher than all the others, but it seemed to be the case. So if you have more information about that, let us know why Azure is offering or charging nearly 5 times the amount, 5 times the price compared to the other solutions. Maybe there's a different storage or better storage, or I don't know. We talked about backup and stuff like that already. That comes with every cloud provider. So it's a little bit more. So as Alex said, storage is not the most important one, but we also have to say that 5 times the price. When you store some log information and some web analytics information with a bigger company, is 1 terabyte also not much. So good. Computation.
So here we also have to divide between different aspects. So for example, it can differ, or the pricing calculation can differ in terms, for example, if you are charging for the amount of time the query is running or the queries are running, and for example, the amount of data which are getting transformed. So for example, for BigQuery, relatively simple. 1 terabyte of transforming data, really important, is $5. So every time you execute a query, also in the upper front of the UI, you already see how much data it's processing. And then you can quickly calculate how much it costs.
Which you're not doing in reality, basically, right? You just look, when you use the database, you have a quite good idea what you're querying, if you do that the day in, day out. And sometimes when you query bigger data sets, you just have a brief look if it's half a terabyte, 1 terabyte or more. And then you might optimize your query a little bit, or go for different ways of pushing the cost down.
But for BigQuery, to give some more insights, you can reduce the amount of data you are processing with table sharding or partitioning. So for example, to quickly explain partitioning, you can divide every table by a partition. So you can say, okay, I have the state column in my table and I want to partition the table with that partitioning date. Let's do a quick example. If you are calculating every day the data of just today, and you have already data of the last 7 years in it, then you can quickly estimate or transform every hour, every minute, whatever you need, the data of just today. Then you drop off the current partition of the current date, you drop off, and you put in the new data of the new partition inside. And that's really quick, and that's also really cost effective, because the table does not have to scan all the rows inside and have to look, is that the current date? No, it's not. It just have to check, that's the current partition. I drop off and put in the new one. So that's really effective. So maybe then we can continue with Snowflake, because Snowflake, one of the biggest thing is that it's charging for the runtime of the query. So not for the transforming data.
The data which is read.
Exactly. So how long the query runs. So as a quick example, if you are doing a select star in BigQuery of a table, you are querying all of the data. And you read all of the data, so that's quite expensive, and you should never do a select star in BigQuery. But in Snowflake, it's really easy, right? Because it just take the whole table and show it to you. So that's really easy. For example, therefore you have in BigQuery a preview feature where you can select the table and say preview. So there you're not getting charged. And then you can also see all of the data. You can quickly explain
the Snowflake. First of all, Snowflake for me is one of the maybe most complex ones. You have two versions of the product, standard and enterprise. Difference you can check on the website. It's like different SLAs and so on. So one is coming for $2 and the other is $3.70, so nearly double the price. $2 means one credit costs you $2 when you use the standard solution. Deciding between using the standard version or the enterprise version is one decision you have to make. The other decision is what kind of infrastructure, like what kind of machine are you using for running your query. You can start with an XS, so-called XS server, going to, I think, XL or even bigger. The difference is that this defines the number of credits you need to pay per hour. So as Alex said, when you run a query, you will get charged for the query runtime. When we talk about the XS server, so the smallest server which is available at Snowflake, you will pay 1 credit per hour. If your query is running, let's say, half an hour, let's make a big example here, half an hour, you pay half a credit times $2, you will pay $1 for this particular query for half an hour. For the smallest server, for the smallest project. We also have to say that the bigger the server is getting, the quicker the query is running, but also the more expensive the credit is. Or the more credits you need to use for 1 hour. And that's the correct term. So that's Snowflake. For Azure and Redshift, maybe you can
they're also quite similar. So there's also more importantly nodes you are using. So for Azure Synapse, for example, they are called data warehouse units. So they are containing computing, working, storaging, and also the in and output of the data. It's all handled by that and also charged for that. So for example, for 1,000 data warehouse units, you have to call, or they are cost $1.20.
100, not 1,000.
100 sorry.
Data warehouse units.
Yeah, sorry. And for 200, then 2.40. So
it's quite linear. Yeah. So for 3,000, you pay $360.
Just to mention it again, so here we don't know, for example, how much you can do with, for example, 100 data warehouse units. So if you have some experience with Azure Synapse and you know your data and how much you're transforming it and so on, would be really interesting to know in the comments, how much you can do with, for example, 100, 2,000, whatever data warehouse.
Maybe describe your use case a little bit, that also the other readers know, okay, this is the amount of queries I run, this is the amount of data size I'm using, that it's a little bit like comparable, but it would be super interesting to know what does 100 data warehouse units mean. Same for Redshift. Redshift, you also need to configure your clusters while purchasing reserved nodes. Or no, you can purchase reserved nodes. You don't need to. You can also work on demand, as far as I know. It comes with a price from 24 cents per hour up to $13 per hour. Also there, we are not super sure how big the node need to be for running certain jobs. What we can say in general is don't start with nodes which are too big, because normally also the very small nodes can do massive jobs. Yeah, because what we think sometimes in e-commerce or in like middle-sized companies is quite a big amount of data, is quite a big query, usually turns out to be, compared to other like markets, very low. And small servers are doing the job as good as the big ones. So rather start with the small ones. If you have issues, it's running too long and so on, try a bigger one and go from that direction, except of top down. Yeah. That are the biggest differences, to say it like that. As we said, maybe as a quick summary, how are you choosing your perfect solution? I think, as I said at the beginning, it's a mix between the setup phase, the administration, management, scalability. Yeah. So, how much do I want to invest over a couple of time, how much do I want to administrate my machines behind the system. If I don't want to do that, I think BigQuery or the serverless version of Azure is quite a good fit to have the ecosystem. When we do that decision in our head, because it's really a difference if everyone has already a Microsoft ID or not, then to go to Google, for example. It's also often a political decision inside the company. So also check that with your colleagues, with the IT team. At the end, I can only say, test it out, try it a little bit, take a bigger amount of data set, load it inside. I think just to spin up any instance and get a node running for all systems, there are good YouTube videos, first of all, I guess. For BigQuery, we have a Udemy course, which is really not that expensive. And you can
look at benchmarks.
Yeah, look at benchmarks. That's a good point. Normally, BigQuery is at the lower range of the benchmarks. I think looking at the real examples they use, the reason is that for all the other solutions, you can tweak your machines. For BigQuery, you can't. So you need to live with what BigQuery gives you, which is in average very good. But if you use very, very, very complex queries with really big amount of data, it can be that the other databases are outperforming BigQuery by some minutes. And we're here talking about query running times of 15 to 20 minutes, I guess. So 2 minutes are then maybe not the biggest issue, but this everyone needs to decide for himself. But really check which use cases they use for the benchmark. Also, they usually say how much costs there were for storage, for computation. But what they don't say is that if you, for example, use AWS or a Snowflake and you have let's say, better performance, then you normally also need someone in the company who takes care of the administrational part, which also has costs or has costs coming with it. So really check that a little bit and give us your ideas. Also, if you're super experienced Azure user, write a story inside and try to sell it to everyone. And that's super important because I think I said it at the beginning, we are a little bit biased to BigQuery. That comes with the fact that we use that day in and day out. Otherwise, thanks for your time. See you in the next video. Next one, which is coming up, is transformation. So what are we doing then with the data when it's inside the database? Ricardo will be back.
Hopefully.
And have a good day. Thanks from Alex and Thomas.
Bye-bye. Bye.